Hello, and welcome back to Political Science 4781, Techniques of Political Analysis, Visualizing and Interpreting Data. By now, a lot of you have gotten your feet wet with R, and I suspect many of you are not exactly looking forward to further encounters with it. But I can promise you, it's well worth the trouble to get to know the language. There are a lot of different things that you can do in it, and one of the ones the main one that I want to cover today is the plot command. Now, you might not think it takes a lot of time to cover the plot command, but the great thing about plot commands and similar commands in R is their versatility. And their versatility comes from the options, the subcommands that you can add to a plot. And most of those are listed under PAR. So if you type in $PAR into R, you'll get a long list of things that you can customize on a plot. So let's take a look. So the first thing we're going to do, since I'm going to be using some random numbers in this demonstration, is to set the seed for R to use to draw random numbers. It doesn't really matter exactly what that means. All it means is you're going to get the same random numbers every time. So the first thing I'm going to do is draw two variables, x and y, and we're going to draw those from a normal distribution with a mean of 0 and a standard deviation of 1. If you've seen a bell curve, you've seen a normal distribution. And we're going to plot these against each other just for illustrative purposes. Now, we're also going to draw a third variable, which is drawn from a uniform distribution from 0 to 2. That means every number between 0 and 2, including 0 and 2, even fractional numbers, is equally likely to be drawn. And I'll show you why we're doing this in a few minutes. And finally, we're going to draw a fourth variable. We're going to call it k, and this is just going to be 25 samples from the numbers 1 to 3 with replacement. So what this amounts to is basically a string of 25 character long or 25 number long vector consisting of ones, twos, and threes that are drawn at random. So, all right, the first thing we're going to do is plot x against y. And this is, to say the least, a pretty uninspiring plot. It really, from an aesthetic point of view, from an informational point of view, it gets the job done. Right? It shows you where the dots are relative to one another. But it's not the prettiest thing, especially since we've just been through a lecture on beauty in plots. So what I want to show is that basically the plot command is one of the most versatile commands in the entire R language. You can do a ton of different things with it. And you can get a surprisingly good-looking graph and a graph that does a whole lot for you in terms of representing information with not a lot of work. So let's run through a couple of things you can do. All of this stuff, I should mention, as I mentioned a couple of minutes ago, is based on the PAR command. And here we're going to use the PAR command to set the background to yellow and then produce the same plot. Right? So that's one quick example of how the PAR command works. Let's set it back to white because that yellow is awful. But when you look under PAR, you'll see that there are a lot of parameters that can be set within the plot command itself, like bty here, which is box type. So you see this box around the plot, right? You see a slightly darker line down here where the axes are drawn, but what I want you to look at is the box surrounding it. You can make that box any number of different shapes. You can use box type L for an L-shaped box, box type 7 for a box that's shaped like a 7, box type C if you want a box that is, sure enough, shaped like a C. So you're starting to get the trend. Box type U, box type right bracket, and box type N for no box at all, just the axes sitting there. Now, another thing you can do if you want to customize your plot is to alter the size of the plot symbols. So if the circles were too small for you earlier, You can make them larger using the CEX subcommand, or you can make them smaller using the CEX subcommand. The default value for CEX is 1. If you put in a number bigger than 1, like 2, you get a larger symbols plotted. If you put in a smaller number, like 0.5, you get smaller symbols. Now here's one of the ways that you can take advantage of this command, is to do exactly what Hans Rosling did in the Gapminder demonstration, and use the size of the plots to represent some third variable, in this case W. So when you do this, right, you're going to see the size of the plots. Remember, in his video, the size of the plots represented population. In this, it just represents a random number between 0 and 2, right? But you can use it to represent all sorts of things very effectively. Now, what if we want to change the labels, these labels, the numeric labels on the axis? What if we think the size is not quite right on those? Same principle applies, the CEX command, except it's CEX.axis. Right? And when we change CEX.axis, what we see is all it does is change the size of the numbers on the axis. Some of these, I should note, you're going to find more useful than others. I don't know that I've changed the axis size very much at all in anything that I've ever done with R, but it's there if you want it. You can also add a title across the top unimaginatively. We are going to call this My Plot. And as you might anticipate, with CEX, with a different version of CEX subcommand, CEX.main, we can change the size of the main title to make it larger or smaller. Now, what happens if we want to label the axes? We don't like X and Y; they're pretty boring. We want to call them something else. Well, we just use the XLab and YLab commands to label the X and the Y axes respectively. So we can call the X axis horizontal axis name, and we can call the vertical axis name. I have to confess, I was not long on imagination when I was putting all of this code together. Okay, what happens if you get tired of black and white? Right? Most of these plots so far have been straight up black and white. Well, it's not too difficult. Oops, it's difficult if you hit the wrong key combination. It's not too difficult in general to change the color of the symbols. Now, there are two ways you can do this. You always use the COL equals subcommand here. Color equals red, color equals blue, color equals gray 70. There are 99 different values of gray from 00 to 90. It's 100 from 00 to 99 that you can choose. Steel blue, or any of the colors on the list of color names that R recognizes, and there are a lot of them. As you can see, there isn't just one steel blue. There are 5 different versions of steel blue that you can use. You can not only use peach puff, orchid, pale green, a bunch of different light yellows. There's even a light steel blue. There is misty rose. There is Navajo white. There are 5 different Navajo whites. So there are a lot of colors here that you can explore for a graph, or for colors on a graph. If you need even more control than that, you can use the RGB color scheme, which is 6 numbers in hexadecimal. That means that these numbers run from 0 to F, which stands for 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And when they are at their maximum, there are 3 blocks here. The first block is how red is the color, the second block is how green is the color, and the third is how blue is the color. So what we've got here, just color FF0000, that's going to give us straight up red. If I can go find the plot. Right. Now also, this is a neat trick that works on some systems and not others. It generally works on Macintoshes. I can't vouch for Windows systems. A 7th and 8th digit, which also run from 0 to F, and they give you the level of opacity. That is, FF is completely dark. 00 means there's nothing there to see at all, and all the numbers in between reflect different levels of. Oops, I should have known better than that. different levels of opacity. So here you see a fairly washed out version of red, which we've made not very opaque, that is mostly transparent through use of the 7th and 8th digits. So there are a lot of ways to specify color in R. That does not solve the problem of making your colors look good, and that's what the R Color Brewer library is designed for. It's made for people who want to make choropleth maps, but it works very well for just ordinary plots. And the way you use it is you import the library. If you don't have it, you go up here to Packages and Data, and you use the package installer to find it. And then you create a vector of colors. We're going to call this My Colors. And you use the brewer pal command to say, give me a palette of 3 colors. It can be anywhere from 3 to 8 or 9, depending on what the palette is. And I want them to be in the yellow, orange, red spectrum. Now, if you type $color brewer, you'll get a list of all the different possibilities that you have for a palette to draw from. So here we've created 3 colors drawn from the yellow, orange, red spectrum. They're basically going to be yellow, orange, and red. And when we specify the color, instead of saying something that R already knows or giving it an RGB code, we're going to say use the colors from my color palette. Now, this is actually a very clever way of including a 4th variable into your analysis, right, into your plot. The first variables you had were X and Y, then the 3rd variable that you had was size, and the 4th variable is going to be color. And again, if you remember the Gapminder plots, color represented which continent or subcontinent or part of the world the country was located in. So, what happens if you get tired of circles? They do have their advantage in that you can see overlapping dots fairly easily, but they're also not quite as easy to see as some other characters. Well, R has about 25 different characters available for you to access using the PCH subcommand in plot. They are just about all here. So if you experiment or look in the documentation, you should be able to find the symbol that interests you. I'm going to use, just for this, a solid dot, which is PCH 19. So what else can we futz around with? Well, we've got axis values that we can color in. We can make them whatever color we want. I should emphasize that this is ripe for horrendous abuse. You could produce the most noxious colored plot in the universe using all these different commands. You shouldn't need to use most of them most of the time. But it's nice to know that if you want to change the axis label or the main title or the color of those things, or of the box itself surrounding the plot, you can totally do that. It's very straightforward. Using the col axis, col lab, col main, and I forget how I got this one. Oh, foreground, right? Foreground color. So another interesting thing you can do with subcommands. Now watch carefully on the y-axis. These numbers are all sideways. What happens if you want them to be right side up? You can do that if you think that'd be easier to read. You can use the LAS command, and that takes on a few different values. If you do $PAR and scroll down to LAS, you'll see all the different values and what they do. Another thing that we might want to do is capture the central tendency of the data. That is, we're looking at these dots. It looks to me kind of like Y is generally increasing a little bit as X gets larger, but it's sort of hard to tell because the dots are so scattered, right? Well, we can borrow a trick from next semester's textbook. We can use linear regression, which is a technique basically that draws a line through the middle of a cloud of data, and the line is representative of the central tendency of the data. And if we do that with an AB line command, and LM just stands for linear model, and you'll want to do Y distributed as X. And again, stay tuned until next semester to figure out what all of that means. And then tell it you want the color blue. It'll give you a nice line that represents the central tendency of the data. You can also change, using the LWD subcommand, the width of the line. If you don't think that the central tendency of the data is quite linear, oh, I'm sorry. If you want to use a dashed line, you can change LTY in the AB line command. And again, $PAR, scroll down to LTY, you'll see there are a variety of different line types. Here we've just got an ordinary dashed line. Now, as I was saying a moment ago, what happens if you don't think the central tendency of the data are quite linear? Well, that's when it comes time to use the LOS command. And for reasons that are too arcane to worry about, instead of using AB line, you use the command lines with LOS. And again, you tell it what color you want it to be. So this is giving us a sort of a picture of, a more localized picture of the central tendency of the data. Now, you might, it's sort of arbitrary how smooth or crinkly that line is going to be. So if you think that doesn't really look, if you think it's sort of overfitting the data and producing, too many curves, what you can do is fiddle with the F parameter inside the LOS command. It's normally set at 2/3. If you set it at 1, you'll get a smoother curve. If you set it at higher values, you get even smoother. If you set it at lower values, the line will become even more curvy. Okay. Another thing that you might find that you want to do, sort of a nice finishing touch sometimes, occasionally people want to know where the axes are. So you can draw using AB line. What this is saying is, give me an AB line, a vertical line at x equals 0, and give me the color gray 90, which is a very faint gray. You can do the same for a horizontal line. Give me AB line, a horizontal line at y equals 0, and again make the color gray 90. Now, you don't need to do these necessarily at the axes. You can put the lines really anywhere you want, and they can be in any color you want. So again, it's really versatile in terms of what you do. Now, one thing that always bugs me a lot of the time when you start up, when you make a plot to begin with, the axes, the limits of the axes don't really correspond to what intuition would suggest. So in this case, for example, we have x going from -2 almost to 2, but there's no 2 label here. And on the y-axis, we've got the y values going from 2 almost down to -2, but there's no -2. And there are values below -1, so you would think that you'd want the limits of the graph to be the actual limits of the data. Well, you can do that using the xlim and the ylim commands. Here we're going to specify xlim goes from -2 to 2, right? That'll get us all the way to 2. And ylim also goes from -2 all the way up to 2. So when we plot this, what we see is we've got the full range of the axes included in the plot. Now, you can do one of my favorite commands, and I'll blow this up a little so you can see. Let's do this again. So the text command allows you to put text in sort of arbitrary places on the screen. So if you want to identify, the scatter plot that represents your observation in this data set, you can put a name right next to it, right? Or you can put text anywhere on the screen representing really anything. And finally, a really fun twist with the RGL library is the plot 3D command, which gives you the ability, in this case, to look at W, X, and Y in 3 dimensions, but not only to look at them in 3 dimensions. Right? This is not the greatest perspective on this data set. And what happens if we grab on here and turn it around? Right? So you can observe all these different colors and all these different observations from a wide range of different perspectives. So that is it for this video. The main thing that I wanted to emphasize is how incredibly versatile R is. It often looks, when you start out, plotting as though it produces relatively ordinary plots, but really nothing could be further from the case. There's a lot of variation in what R can do, and it's up to you to explore, and primarily to look at existing examples online and in the R Graphs cookbook and in the PAR documentation to see exactly what's possible.